Hello, friends and dear viewers. I welcome you all to this current episode wherein we are going to discuss about the physical or mechanical weathering. Of course, it's a very interesting topic with regard to geography when compared to ecology. Friends, I'm going to give a detailed or deep insights with regard to the physical or mechanical weathering. Right, friends? Let's move. Mechanical weathering is the physical disintegration of a rock by the actual pricing apart of separate particles, or physical weathering is the disintegration of rocks by mechanical process and various factors with various factors. This can happen even with a completely fresh rock, but the processes of physical weathering are able to work much more easily when the surface of rock has already been weakened by the action of chemical weathering. Friends, you understand, I think. Physical weathering, of course, is a process, but it can operate easily whenever and wherever the chemical weathering has already been taken up. Right? Mechanical weathering, it generally moves speedily when the surface of the rock has already been weakened by the action of chemical weathering. Right. Mechanical weathering takes place in several ways. It takes place in several ways, and of course, the first one and the first condition, that is the repeated temperature changes. Friends, hope you understand. Repeated temperature changes. This is one of the way by which mechanical weathering takes place. Now let's go in detail about the repeated temperature changes. Right. In deserts, where the rocks are exposed to the blazing sun during the day and are intensely heated, uh, these outer layers, they expand much faster than the cooler interior of the rocks and tend to pull away from the rest. I come back once again, friends. If you observe the desert, where of course you can find a number of rocks there, in desert where rocks are exposed to the blazing sun during the day, they are intensely heated, and of course the outer layers they expand much faster than the cooler interior of the rocks, and they tend to pull away from the rest. At nightfall, generally the temperature drops rapidly and the outer layers they contract more rapidly than the interior. A reverse, a reversal process, dear friends. During daytime and due to the extreme temperatures, and that is due to the blazing suns, the external layers of the rock they used to become very hot, and due to that intense heat, they get they expand much faster when compared to the interior region. And similarly and contrastingly, during the nights in deserts, there are very contrasting conditions. It is quite opposite condition, dear friends. And during daytime, we find extreme temperatures, extreme hike in temperatures, and similarly and contrarily, during the nights you find extreme low temperatures, extreme low temperatures. So that is the reason why you find so much cool effect in deserts, right? At nightfall, the temperature drops rapidly, and the outer layers they contract more rapidly than the interior, setting up the internal stresses. And such stresses repeated every day for months and years, and that cause the rocks to crack and split. That is the reason experiencing intense heat during daytime and extreme cold conditions during the night time, these upper layers of the rock they are affected over a period of time, that may be few months or few years, and later these rocks they get crack and split. Well bedded and jointed rocks tend to split along the joints or cracks, breaking up into the rectangular blocks. Friends, shales and slates, shales and slates may split up into platy fragments because of their platy structure. Okay, in crystalline rocks such as granite, the crystals of the various minerals, like earlier I disclosed that the quartz, mica, feldspar, will expand and contract at different rates, enhancing the stresses and accelerating the disintegration of the rocks. So, fragments broken from the large rock outcrops fall by gravity to the foot of the slope. They may form screes, they may form screes or may form a litter of angular chips and small boulders on the flatter ground. I repeat once again, fragments broken from large rock outcrops fall by gravity to the foot of the slope. They may form screes or may form a litter of angular chips and small boulders on the flatter ground. Stresses and pressures will naturally be greatest near the surface, and where there are sharp angles in the rocks. Rectangular blocks are thus gradually rounded by the splitting away of sharp corners, and when the surface layers of rounded boulders gradually split off, the process is called onion peeling. This is called as onion peeling because the various layers look like the layers of an onion peeled off one after the another. And you have a technical term for this process, and that is nothing but the exfoliation. So, friends, exfoliation is the process where the surface layers of rounded boulders gradually split off and looking like onion peeling. Okay, this surface layers, of course, it's nothing but due to, experiencing temperature variations, and in a course of time, the external layers they are peeled off and looks like onion peeling, and this process on the whole can technically be called as exfoliation. That is called as exfoliation. Right, my dear friends, and now move on to um, the other one, repeated wetting and drying. Repeated wetting and drying. Exfoliation is not confined to desert areas. Friends, I think you got a very good understanding about exfoliation. That is nothing but the peeling off the surface layers of rock. And we have taken example a desert condition or a desert habitat. And whereas the other process, that is repeated wetting and drying. And in this condition and in these circumstances, exfoliation is not confined to desert areas. Of course, similar stresses may be set up in rocks by repeated wetting and drying of the surface layers. Friends, it is very much clear. The surface layers of rocks necessarily need not experience high temperatures during daytimes and very low temperatures during night times, which helps in creating stresses that ultimately leads to exfoliation processes. But it is repeated wetting and drying process are also places place a similar effect, and it helps in creating the same effect, dear friends. Similar stresses are also set up in the rocks by repeated wetting and drying of the surface layers. And this takes place especially in tropical regions. Again, the example can be Malaysia, where short downpours saturate the rocks and then the hot sun quickly dries them again. So, wetting and again drying process has taken up. Repeated wetting and drying also occurs at the coast where rocks may be rapidly dried up by sun and wind between tides. When rocks are wetted, the outer layers absorb a certain amount of moisture and expand. And when they dry, This moisture evaporates and they quickly shrink. They quickly shrink. When this happens repeatedly, the outer layers they split off. It should also be stressed that the wetting and drying of the rocks in deserts is probably just as important as temperature changes in mechanical weathering. Right? The rocks dry very quickly, indeed, after being wetted by the brief desert rainstorms. Okay, now comes the other form, that is the frost action. That is the frost action or frost weathering. Frost weathering. In temperate latitudes, friends, repeatedly we are coming across these words, so you should bear in your mind and you should be able to imagine the globe. What are the places or the countries that falls under temperate regions? Okay, right. During this frost weathering, in temperate latitudes, frost is a potent rock breaker. All rocks contain cracks and joints, we know very well, or pore spaces, and after a shower water or snow, if it collects in such places, and when the temperature drops at night or during the winter, this water freezes. This water freezes, and when this water freezes, it expands by 1/10 its volume. When this water freezes, it expands by 1/10 its volume and exerts a bursting pressure of almost 140 kilograms per square centimeters. That is nothing but 2000 lbs to the square inch. I repeat once again, my dear friends. Generally, in temperate latitudes, you find shower water or snow. When that collects in the joints of the rocks, and due to extremities in temperatures, and that to the cool temperatures or low temperatures, this water they get it becomes frozen, and due to that frozen activity, particular place it gets expanded by 1/10 its volume, and thereby exerting a bursting pressure of about 140 kilograms per square centimeter, which could be about 2000 lbs to the square inch. Right. A repeated freezing of this kind will deepen and widen the original cracks and crevices and breaks the rock into angular fragments. Okay. On mountain peaks, this process creates sharp pinnacles, pinnacles and angular outlines. Such peaks they are described as such peaks they are described as frost shattered peaks. Frost shattered peaks. Angular fragments of rock are prized from mountain slides or cliff faces, and they fall to the foot of the slope where they accumulate to form screes. Hope, dear friends, I used the word screes in my earlier explanation or earlier discussion. Hope you got it. The angular fragments of a rock are prized from mountain sides or cliff faces and fall to the foot of the slope where they accumulate to form screes, right? And now it's the turn of the biotic factors which help in weathering, right? Small fragments of rock loosened by either chemical or mechanical weathering lodge in cracks and crevices in the rock, and plants may sprout in such crevices. We can generally find this kind of situations at many places. We evidence this kind of situation, and even some upon some walls also you can find this kind of situation. Residential buildings, walls, compound walls, etc. And as they grow up, the roots penetrate the rocks below, and usually along the joints and other lines of weakness, pricing them apart. You have often come across large trees growing near roads or the country yards of houses that finally prise open the concrete or paving stones above their roots. The process is just the same on a smaller scale in a natural setting, also different. I can give you a beautiful illustration pertaining to this biotic factors contributing to weathering. Right. It's time for us to deal with the important topic, dear friends, that is mass movement. Right? Mass movement. Mass movement is the movement of it is the movement of weathered it is the movement of weathered materials down a slope due to gravitational forces. Due to gravitational forces. The movement may be gradual or sudden. And depending on the gradient of the slope, the weight of the weathered debris and whether there is any lubricating moisture supplied by rainwater. And several kinds of mass movements are distinguished. Several kinds of mass movements are distinguished, and of course, the soil creep. Of course, the soil creep. Soil creep is a slow, gradual, but more or less continuous movement of soil down hill slopes. The movement is not very noticeable, especially when the slope is fairly gentle or when the soil is well covered with grass or other vegetation. Soil creep is most common in damp as well as damp soils where the water acts as a lubricant so that individual soil particles move over each other and over the underlying rock. It is also found where continuous trampling by animals grazing on the slopes sets up vibrations which loosen the soil and cause it to move. Though the movement is slow and cannot readily be seen in action, the gradual movement tilts so that trees, fences, posts, and so on and so forth, which are rooted in the soil. The soil is also seen to accumulate at the foot of the slope or behind obstacles such as walls, and these may eventually be burst by the weight of soil. So, friends, I give a beautiful illustration or presentation so that you can see or you can evidence this in a diagrammatic manner. Now, it is the soil flow. Soil flow is also called as solifluction. It is also called as solifluction. When the soil is completely saturated with water, the individual particles are almost suspended in the water and move easily over one another and over the underlying rock. The soil acts like a liquid, and a soil flow or mud flow occurs. Friends, if you imagine the arid regions, in arid regions, a mantle of weathered debris may become saturated with rainwater after a storm and flow downslope as a semi-liquid mass. In temperate and tundra regions, I come again once again, friends. In temperate and tundra regions are basically the regions which are, between subpolar and polar. They can better be called as tundra regions, where soil flows occur when the surface layers of frozen ground thaw in the springs. Soil and rock debris, which is lubricated by the melting water, and thereby they flow easily over the underlying frozen subsoil. In areas of peat soils, the peat absorbs much moisture. However, if saturation point is reached, the peaty soil may flow downslope. And this soil flow towards the downslope it may be called by many terms. If you take particularly Ireland, the country Ireland, in Ireland, these peaty soil flow towards the downslope is known as bog bursts. It's known as bog bursts. Friends, so far we have discussed about this soil flow, and the next one could be the landslides. And this is also called as slumping or sliding. So, friends, I think we should conclude our episode and hope let's take a fresh session or episode so that we can have a deep insights into the topic landslides. Hope you enjoyed this session. Thank you one and all.